Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें फ्रेनेल्स हाफ पीरियड जोन्स आउ रेक्टिलिनियर प्रोपागेशन ऑफ लाइट ए विषय रे पढिबा सो ये जो हाफ पीरियड जोन्स एक्चुअली तुमरो सिलेबस रे प्लेन वेव पाई दिया हिची तबे बिसाइड्स दैट वी कैन आल्सो हैव द हाफ पीरियड जोन्स फॉर द सिलिंड्रिकल वेव ओके से जा भी हो फर्स्ट हमें कंसीडर करबा गोटे प्लेन वेव एज यू कैन सी ए बी सी डी एटा हला गोटे प्लेन वेव व्हिच इज परपेंडिकुलर टू द डायरेक्शन ऑफ प्रोपागेशन वेव नाउ here S is the source of light which is emitting the plane wavefront and it is suppose having a wavelength lambda, right? And now here the point P is the point of observation where all the waves will have a phase difference due to two regions. Gote hela obliquences of the waves reaching the point P from various points of the wavefront and they will have different values of obliquences माने ए जो सपोज फॉर एग्जांपल एस ओ पी ओके एथिपाई आमे जदि ऑब्लिक्वेंसेस बा ऑब्लिक्विटी फैक्टर जोटा देखिबा ताले याकू जदि कंपेयर करबा एस एम सेवेन पी सहित ताले एंगलटा चेंज हो जाउची समान एंगल नुह ओके सो देयर आर डिफरेंट ऑब्लिक्वेंसेस एंड दे आर क्रिएटिंग फेज डिफरेंस ये हला फर्स्ट फैक्टर तापर सेकंड फैक्टर हला different distances are traveled by the waves from different points again SOP a distance टा होची सबुठु कम बा smallest आउ SM7P this distance is the largest so distance अलगा हो जाउची and it is again creating phase differences right so amar काम होला we have to calculate or determine the resultant effect at this point of observation P due to the entire wavefront which is actually at a distance x okay horizontal distance x रे अछि ए point P टा okay from the point O that is PO equal to x okay acha now we divide the entire wavefront into elementary regions or strips and these are called zones or Fresnel zones having center at this point which is O right now let us draw concentric imaginary spheres okay concentric imaginary spheres ei bhaliya ame draw kariba such that they are having the center at this point O and radius will be how much the radius will be pm1 this is then pm2 pm3 and so on okay so ये radius value को हमें लिखि परिबा first जदि देखिबा pm1 this will be how much x plus lambda by 2 right similarly pm2 ପାଇଁ एटा हे जिवो केते x plus 2 into lambda by 2 that is x plus lambda ये हला pm2 रो वैल्यू तापरे pm3 यारो वैल्यू टा हेबो x plus pm3 ପାଇଁ x plus 3 lambda by 2 right and so on so एबे जदि हमें देखिबा एक्चुअली द वेव फ्रंट जो अछि एठी ए जो वेव फ्रंट टा दिस इज एक्चुअली कट इनटू concentric circles okay ए जो concentric circles गुडा देखुछो okay having the center at O and radius एबे केते ही गला ए सर्किल पई OM1 then OM2 OM3 and so on right so the area between two spheres will be called as the half period zones okay दुईटा sphere भितरे जो area टा रहुची that is called as half period zone and the point O here is called the pole of the wavefront with respect to the point of observation, that is P, right? Now since the waves from corresponding points of adjacent areas differ in path by half the wavelength, ଯେମିତି ଆମେ ଦେଖିଲା x plus lambda by 2 ର इंटीग्रल फैक्टर होता राइट बिकज ये जो वेव फ्रंट रो जदि आम एडजसेंट एरिया गुड़ार देखा पाथ डिफरेंस दिस इज नथिंग बट हाफ ऑफ द wavelength, that is lambda by 2. So the annular rings in the wavefront are called as half period zones. एइथिपाई ही ये जो annular rings गुड़ा को आमे half period zones बोले कि कहिबा और simply Fresnel zones बोले कि कहिबा, right? And in these Fresnel zones the waves reach the points with the time delay of half time period. Okay, because एठी जेहेतु path difference टा lambda by 2 अछि, so एबे time delay हेबो केते प्रति आमे जोन रो जदि टाइम डिलेटा कैलकुलेट करिबा ताले इट विल बी हाफ टाइम पीरियड, राइट? एंड द पॉइंट ओ हियर, ओके, ये जो पॉइंट ओ बा सेंटरटा अछि दिस इज नोन एज द पोल ऑफ द वेव फ्रंट विथ रेस्पेक्ट टू द पॉइंट ऑफ ऑब्जर्वेशन पी. ओके, सो एबे हमरो टास्क हैला ये जो हाफ पीरियड जोन अछि यार एबे आमे रेडियस बाहर करिबा. ओके, द रेडी ऑफ द हाफ पीरियड जोन्स. ओके, सो फर्स्ट हाफ पीरियड जोन पाई रेडियस ही गला केते OM1 याको आमे लिखि परिबा PM1 स्क्वायर माइनस PO स्क्वायर रो स्क्वायर रूट. ओके, सो यार वैल्यू आमे पुट कर देला and we solve it. Okay, so this is coming out to be the x square plus or minus ochi kotigala. Okay, and we are neglecting this lambda square by 4 because it is a very small term, so this is coming out to be square root of x lambda. Similarly, the radius of the second half period zone, that is OM2, will come out to be square root of 2x lambda. So in general जदि आमे देखिबा nth हाफ पीरियड जोन ता पई एबे रेडियस टा हेगला सपोज OMN, ताले यार वैल्यू एबे केते हबो स्क्वायर रूट ऑफ nx lambda, right? Hence the radii of the half period zones is proportional to the square root of natural numbers, right? अच्छा, ये हैला रेडी. एबे देखिबा यार एरिया ऑफ द हाफ पीरियड जोन्स. सो nth जोन पाई जदि आमे एरिया बाहर करिबा ताले this will be how much? Area of nth zone is equal to area of first n number of zones minus area of first n minus 1 number of zones. Okay, that means pi into OMN. Okay, এটা হচ্ছে radius nth zone পাই. Okay, ଆଉ minus করଛୁ ଆମେ ଏଠି pi OMN minus 1 ର square. Okay, এটা হচ্ছে radius n minus 1th zone पाई. Okay, so याको आमे again put करिबा यार जो value गुडा ऊपर पाइथिला, so its value is coming out to be pi x lambda. गोटे important जिंस एबे लक्ष्य करो, area जो nth zone रो it is independent of n. Hence we conclude that the area of nth zone is independent of the number. Okay, से को number रो zone ता ऊपर depend करू नाही यार area. Okay, so area ता माने in other words area of each zone. Okay, and you can say every zone is found out to be constant because n upare depend hi karu nahi. Okay, its value is pi x lambda. Okay, so although the area of each zone is same, but radii of the zones will be proportional to square root of n. This is very important. Okay, तापरे next आकु बढ़िबा distance of the point of observation P from the half period zone. Okay, याकु जदि आमे बाहर करिबा it is given by x plus n lambda by 2 plus x plus n minus 1 lambda by 2 divided by 2. Okay, so याकु जदि आमे solve करूछु this will be coming out to be x plus 2n minus 1 lambda by 4. Okay, so this is the distance of the point P from the half period zone, right? Acha, then the amplitude of the wavelet at the point of observation P. So ये जो amplitude due to one zone, actually it depends on the following factors. Okay, तीनटा factor अछि. Number one, it is directly proportional to the area of the zone. Number 2, the amplitude falls off inversely as the square of the distance of the zone from the point of observation P. Now, third point যদি দেখিবা, the amplitude depends upon the obliquity. जो obliquence ଆମେ ଦେଖୁଥିଲା, it depends upon the obliquity of each zone. Okay, so obliquity মানে কোন? It is the angle between the normal to the wavefront and the line joining the point P to the zone. Okay, so mathematically ଆମେ ଯଦି ବୁଝିବା, amplitude is measured as directly proportional to half times of 1 plus cos theta. এটা ଆସୁଛି obliquity factor ତା ସହିତ half multiply ହେଇଛି ତା ମାନେ, right? So ଯଦି ଆମେ କହିଲା capital Rn is the amplitude at the point P due to the zone মানে nth zone পাই suppose, then this amplitude Rn is equal to the area of the zone into the obliquity factor divided by distance of the point P from the zone. Okay, so याकु सब आमे जदि put करिबा, its value will be pi lambda into 1 plus cos theta by n, right? So with the increase in the number, that is the value of n, the factor cos theta n will also decrease. Okay, and hence the amplitude Rn will decrease, right? अच्छा, so ये गला amplitude of the wavelet at the point of observation P. एबे आमे देखिबा resultant amplitude केते हबो, because एटा ही हमको बाहर करिवार अछि. So resultant amplitude of the point P due to the entire wave front. Okay, so आमे देखिला जे path difference create होउची. Okay, जेतेबेले आमे अलगा अलगा zones रू P आड़ को मूव होउछु, since the path difference between two concentric zones is how much? This is the half of your wavelength, that is lambda by 2. So the two waves will reach in opposite phases, because जदि path difference टा lambda by 2 होउची, ताले phase difference केते हबो? 2 pi by lambda into path difference, that is lambda by 2. So lambda और lambda एठी कटि गला, 2 और 2 कटि गला. So phase difference केते हला? pi माने 180 degree, right? That means they will have opposite phase. बुझियला? So that is why the light from two adjacent half period zones, এটা টিকে printing mistake ଅଛି. Okay, light from two adjacent half period zones will differ in phase by an angle of 180 degree or pi. Okay, so যদি ଆମେ କହିବା R1, R2, R3 and so on are the amplitudes at the point P from various zones, then the resultant amplitude at the point P will be how much? This will be कैपिटल आर जदि या कहला रिजल्टेंट एम्प्लीट्यूड को, ताले R1 तापरे माइनस R2 होबो, काई बिकॉज ऑपोजिट हो जाउची फेजटा सेति पई. ओके, अगेन देन प्लस R3 माइनस R4 सो ऑन अप टू आमे जदि देखिबा माइनस साइन टा को जगह रे प्लस साइन टा को जगह रे याकू ठीक से जदि आमे देखुछु, देन इट विल बी -1 टू द पावर n -1 हबो को टर्म रे nth टर्म रे, राइट? सो हियर R2 actually it is equal to R1 plus R3 by 2, R4 egala R3 plus R5 by 2. Okay, so here we are getting the resultant amplitude capital R equal to R1 by 2 plus Rn by 2 केतेबेले for odd value of n. आ जदि even values रहउची n रो, then its value is equal to R1 by 2 plus Rn minus 1 by 2 minus Rn by 2. Okay, so for larger values of n, you can see here ये जो term दुईटा अछि Rn minus 1 by 2 और Rn by 2, these terms can be neglected when if the value of n is very large. Okay, hence the resultant amplitude at the point P due to the entire wavefront will be simply R1 by 2. That means half times of amplitude of the first half period zone. Okay, this is very important. Okay, so ये हला resultant amplitude. एबे हमरो टास्क हला intensity बाहर करिबा at the point P due to the entire wavefront. आमे जानि छु intensity is directly proportional to the square of the amplitude. Okay, so jodi I hegala yar intensity, then it is, suppose constant of proportionality ko ame negala 1, so I equal to r square. Okay, so r1 by 2 ro whole square, or we are getting r1 square by 4. How r1 square is nothing but I1, okay, which is the intensity due to the first half period zone. So we are getting the intensity at the point P due to the entire wavefront to be equal to 1 by 4th, that is 1/4 times of the intensity due to the first half period zone. Okay, so light ro jo illumination hochi at the point of observation P, it is entirely because of only half the area of the first half period zone. ओके माने फर्स्ट हाफ पीरियड जोन रो जो एरिया अच्छी तार अधा, ओके से एरिया रो अधा जदि आमे बाहर करिबा, दिस इज एक्चुअली रेस्पॉन्सिबल फॉर द light illumination at the point of observation P. Okay, that means light which reaches the point P from the circular area will be equal to how much? Half the area, so half into pi x lambda, okay, which is around the pole O, right? And the remaining wavefront do not contribute any intensity of light at the point P due to the formation of minimage between the wavelets from various zones. Okay, so এই जो area ଆମେ ଦେଖିଲା half pi x lambda, it is actually very small due to the small value of the wavelength lambda, and generally it is considered to be a point size, and it is hence the path OP, which is approximately a straight line. ओके, सो जेहेतु यही एरिया बहुत छोट रही जाऊँगी, सो या आम गोटे पॉइंट साइज बोली धरी नहीं पारिबा. सो द पाथ ओ पी जो है जोटा फिगर आम देखुला, इट विल बी अप्रोक्सीमेटली अ स्ट्रेट लाइन. ओके, सो ये है फ्रेनेल्स हाफ पीरियड जोन्स. नाउ लेट अस सी cylindrical wavefront रे a half period zones केमती create होची, although it is not particularly in your syllabus. Okay, but for the sake of knowledge एटा भी जानी रखो. So we consider a cylindrical wavefront from the source of light. Okay, so we are getting this cylindrical wavefront by means of a narrow slit. Okay, so as shown here in the figure, this is the source and here एक्स वाई होगला ये स्लीटा. सो ये आम वेव फ्रंटा जो पाचु, दिस इज सिलिंड्रिकल, यार जो एनवलपटा अच्छी यहाँ गोटे सिलिंड्रिकल शेप्र आसुची वेव फ्रंटा. राइट, नाउ फ्रॉम द पॉइंट ओ हियर we draw a perpendicular OP, right? OP perpendicular आम draw करिबा on the surface of the wavefront. Now let us say that OP is equal to small a. ताले let x p y, okay, x p y माने ये जो स्लिट तुम देखुच x आउ y तले अच्छी, सो x p y be the section of a cylindrical wavefront. माने ये जो dotted line रे ये भला जदि आमे बाहर करिबा, this will be a section of the cylindrical wavefront in a horizontal plane, right? And select the points r1 r2 r3 and so on xpy on both sides of p. Okay, so देखो ये टिके फिका हो जाइए. ओके, r1 r2 r3 ये भाया आम सिलेक्शन करनेला. Okay, on both sides of the point P such that OR1 equal to a plus lambda by 2. Okay, से जो प्लेन वेव रे जमती आम करथिला से भाया OR2 equal to a plus 2 lambda by 2, or simply a plus lambda, OR3 a plus 3 lambda by 2, and so on, right? So here lambda is obviously the wavelength of light. Now from r1 r2 r3 we draw lines which are parallel to the axis of the cylinder. Okay, ये जो lines हमें draw करूचु which are parallel to the axis of the cylinder. Then the area of the wavefront which is enclosed between two successive parallel lines, माने two adjacent parallel lines, will be known as half period element. Okay, दुईटा parallel line भितरे जो area टा रहिला, that will be known as half period element. And a flat view of the above construction is shown in the second figure. याकु जदि हमें flat करिके देखिबा ताले एठी देखो एटा गोटे एरिया आसिला तापरे एठी एटा आ गोटे एरिया एंड सो ऑन ओके सो it is clear now that the half period elements in this case are situated on both sides of the point P. Okay, point P रो दुई साइड रे half period element रहुची. Okay, so suppose आमे M1, M2, M3 and so on याकू नेगला amplitude. Okay, एटा आ गुटे बही रो नेइची एटा. Okay, previous बही रे याकू से कैपिटल R1 कैपिटल R2 ए भलिया लेखुतला ए amplitude गुडाकू. Okay, सेम जिंस ताले आमे एबे जदि टोटल एम्प्लीट्यूड बाहर करिबा ओके टोटल एम्प्लीट्यूड which is imparted to the point O by various half period elements again same bhaliya capital R will be equal to how much M1 minus M2 plus M3 minus M4 and so on okay minus आसची काहे की because again एठी जेहेतु path difference होची lambda by 2 so phase difference हेगला pi or 180 degree तेणु करी minus आसी जिवो okay so it will be simply equal to m1 by 2 okay already एटा हमें explain करि सरछु जोथिरे कि r equal to r1 by 2 पाइथिला हमें okay एठी r न नै कि आउथरे कहूची small m लिखिची से जा बिउ ताले resultant amplitude at the point O due to the whole wave front will be how much this will be 2r काहे कि एबे 2r हला because देखो पॉइंट पी रो बोथ साइड्स रे अछि ओके गोटे साइड पई हमें पाइला r ताले दुई साइड पई आसी जिवो 2 times of r so 2 into m1 by 2 or simply m1 okay so here the factor 2r corresponds to it लिखि भी देछि the two halves of the wavefront giving light at the point O okay so ये हला cylindrical wavefront by Fresnel's half period zones now at the end let us see the rectilinear propagation of light देखो आम जाचु रेक्टिलिनियर प्रोपागेशन ऑफ लाइट कहले लाइट ट्रैवलिंग इन अ स्ट्रेट लाइन okay and this has already been explained by Fresnel using the principle of interference and Huygens principle of secondary wavelets in the year 1815 so Fresnel kono kale he tried to explain that the rectilinear propagation of light is only approximately true okay pakha pakhi eta true okay he was able to explain that starting from the wavefront as shown in the figure it is first figure ame dekhutila plane wavefront pai okay so a narrow beam of light reaches the point of observation P with base and this is actually base area okay base r no it printing mistake अछि base area which is half pi x lambda eta am bahar kala around the pole O okay now if some opaque object is placed and it is obstructing this narrow cone shaped beam of light then no light can reach the point of observation P right so the opaque object will now cast its shadow at the point P okay so ये जो opaque object आमे सामने रखी देला ताले light ता देहरे पड़ी कि it will create a shadow at the point P okay so if the obstacle is taken to be very small okay it is taken to be very small it are too small nahi too small above okay again printing mistake achi okay then some light may reach the point P after overcoming some obstacle in the path of the light rays okay and this confirms that light deviates from its actual path okay so actually যদি আমি theory দেখিবা light traveling in a straight line এটা deviation আসিলা light ro okay by bending around the small obstacle whose size is taken to be very small okay it is very much closer to the wavelength lambda of the light okay so ये जो deviation देखौछि from the rectilinear propagation or rectilinear path of the light it is referred as the phenomenon of diffraction okay bending of light around the corners of an obstacle okay so in most of the cases we observe that light which is to be traveling in straight line because the size of the obstacle is very large in comparison with the wavelength so diffraction is actually not noticeable object टा जदि बेसी larger size रो हे जाउची ताले diffraction टा एते खास देखा जाय नाही okay and it was the scientist Sommerfeld who defined the term diffraction as any deviation of light rays from its rectilinear path
which can neither be interpreted as reflection nor as refraction. So in this way we observed that light illumination जो होची, that is even in the geometrical shadow region, and this property of light is called as diffraction. Okay, କେତେବେଳେ ଏଟା होची, when the dimensions of the obstacle which is placed in the path of light is very small, that is comparable to the wavelength of light. Okay, so that जो rectilinear propagation बा straight line motion of light rays, actually this will be an approximate concept, okay, due to very short magnitude of wavelength of light. Okay, so this is all about the Fresnel's half period zones and rectilinear propagation of light.
Thank you.